Hello students, welcome back to maths class. My today's topic is triangles. In class 9th you have already studied about congruency. Today we are going to study similarity. Now what do you mean by similar figure? Two figures having same shape are called similar figure, not necessarily the same size. Here are some figures which are similar. You can see that all circles are similar, all equilateral triangles are similar, all squares are similar. All congruent figures are similar, but similar figures not necessarily congruent. Here are some criteria for two polygons to be similar. The polygon must have same number of sides and their corresponding angles must be equal and their corresponding side should be proportional. Similarity of triangles. Two triangles are similar if their corresponding angles are equal and their corresponding sides are proportional. Now, what do you mean by this corresponding sides and corresponding angle that we are going to discuss in this video? So, watch this video and know more about similarity.
Polygons. The goals of this video are to define similarity, determine corresponding parts of similar polygons, and also solve for unknown values of similar polygons. Similar polygons are polygons with the same shape but not the same size. Here we see two similar triangles, two similar pentagons, and two similar rectangles. They're the same shape but different size. To contrast this, here are some polygons that are not similar. These two triangles are not similar because they're not the same shape and obviously not the same size. Same thing with these two pentagons and these two rectangles. They're not the same shape, therefore they are not similar. Now let's talk about the properties of similar polygons. Well, first, similar polygons must have the same number of sides, and that should be pretty straightforward. There's no way a triangle is going to be similar to a rectangle, pentagon, and so on. So these next two properties are key to working with similar polygons. Number two, the corresponding angles are congruent. This idea of corresponding parts is extremely important when working with similar polygons. Let's see if we can identify the corresponding angles in these two similar triangles. Notice that angle C is the angle that looks like it's close to a measure of 90 degrees, and then looking at the larger triangle, angle C would correspond with angle N. And because these two triangles are similar, these two angles are congruent or equal in measure, and we can identify that by using the same number of arcs. Now let's take a look at angle A, which is the angle formed by the shortest side and the longest side of this triangle. It would correspond to angle M in the large triangle. Notice it's formed by the shortest side and the longest side. And again, because these are corresponding angles, they are congruent. And of course that leaves us with angle B congruent to angle O, meaning they're the same measure. Now if we identify the corresponding angles first, it makes it a lot easier to identify the corresponding sides. And the corresponding sides of similar polygons are proportional, which means the ratio of the lengths of the corresponding sides form a proportion. Let's start by identifying the corresponding sides. Side AC corresponds to side MN, and again, the order in which we list the endpoints of these sides is important. They should be listed in corresponding order. And now they're color-coded, it makes it a lot easier. So side AB corresponds to side MO. Notice how we're going from the green vertex to the orange vertex. And then lastly, side BC corresponds to side ON. And because the corresponding sides are proportional, we can create proportions using the lengths of the corresponding sides. Remember, a proportion is when we have ratios equal to each other. So the length of side AC compared to the length of side MN must be equal to the ratio of the length of side AB to the length of side MO, which also must be equal to the ratio of the length of BC to the length of side ON. And we can use this information to solve for unknown values of similar polygons. And the last thing to mention is if we know two polygons are similar, we can use this symbol here to identify similar polygons. So in this case, triangle ABC is similar to triangle, again we need to list these vertices in corresponding order, so it would be MNO.
It should be MON.
Now let's take a look at some examples of how we can use this information.
So triangle
Here's a
ABC
problem where we're given
to
two rectangles
MON.
and we're asked to identify if they're similar. So we need to check two things. We need to make sure the corresponding angles are congruent and corresponding sides are proportional. Well, first, if we know they're both rectangles, all the angles would be 90 degrees and therefore congruent. So now we're left to check to see if corresponding sides are proportional. And again, we know that opposite sides of rectangles are the same length, so this would be 15 and this
All
would be 10.
rectangles are not
This would
similar.
be 12 and
Now
this would be
here
20.
we are checking
So to check to see if
whether
these two rectangles are similar,
or
we
not.
need to check that
Angles
the corresponding
are equal,
sides are proportional.
but sides
And since
must be
this side
proportional.
corresponds to this
So we are
side
checking the
and this
proportionality.
side corresponds to this side, we can write a proportion using these lengths. So the ratio of 10 to 12 must be equal to the ratio of 15 to 20 if these are similar. Now notice how the ratio here was comparing, notice how this first ratio is comparing lengths in the small rectangle to the large rectangle, and we need to be consistent. Notice how the second ratio is also comparing a length in the small rectangle to the large rectangle. So if these two rectangles are similar, this would be a proportion, which means the cross products would be equal. So what you need to check is 10 times 20 equal to 12 times 15. Well, 10 times 20 is 200, and 12 times 15 is equal to 180. Well, those obviously aren't equal, therefore these two rectangles are not similar.
Since the sides are not proportional, the rectangles
If they
are
were
not
similar, these would have been equal. Let's take a look at one more example. Here we're given that these two triangles are similar and we want to solve the two triangles, which means we want to find the length of all of the sides and the measure of all of the angles. Again, let's start by identifying the corresponding angles. Angle C would be the smallest angle in the triangle, so angle C must correspond to angle Z. Angle B is the angle opposite the longest side, so angle B corresponds to angle Y. And that leaves us with angle A corresponding to angle X. And we know that corresponding angles are congruent. So let's start with determining the measure of the three angles. If angle Y is 83 degrees, so is angle B. And if angle C is 41 degrees, angle Z must also be 41 degrees. Notice how we're left with one remaining angle in each triangle, but remember the sum of these three angles must be 180 degrees. So to determine the measure of angle A and the measure of angle X, we can take 180 degrees and then subtract the sum of 83 degrees
Using the angle sum property of triangles,
and 41
we can
degrees.
find the third angle.
So that gives us a measure of 56 degrees for both the measure of angle A and the measure of angle X. And to determine the length of the missing sides, we know the corresponding sides must be proportional. Notice how side AC corresponds to side XZ. So we'll use the ratio of 12 to 18 to get started. So 12 to 18 must be equal to the ratio of the length of BC to the length of YZ. So we'll have 10 over the length of YZ. Since we only have one unknown, we can cross multiply and solve for the length of YZ. Not to get confused by having the length expressed as two variables here, I'm going to go ahead and rewrite this. I'll call this length here m, and this length here n. So we'll delete this and replace it with m. Now we can cross multiply. 12 times m would be 12m must equal 18 times 10, that's 180. Divide by 12, that's going to give us 15. So the length of YZ is 15 units. And now we're left to determine the length of side AB, which we'll just call n. So let's go ahead and use the same ratio of 12 to 18. Notice how this compares the length in the small rectangle to the large rectangle. So 12 to 18 must equal the ratio of n, which is the length of side AB, to the length of side XY, so n to 12. And now we cross multiply. 18 times n, or 18n, must equal 12 times 12, that's 144. Divide by 18. n is equal to 8. Therefore, the length of AB is equal to 8.
In this way, we can find missing angles and sides. I hope it is clear to you.